Set theory, subsets and equal sets. Oftentimes, a collection doesn't contain all of the elements in a set. For example, let's say a museum has 2 Picasso paintings. While these 2 paintings are a set, they are just a portion of all Picasso paintings. Experts estimate Picasso produced about 1,855 paintings. We can say that a set of all these 2 paintings are a subset of the larger set of all Picasso paintings. Now there's an example. We have some formal definitions here. Set A is a subset of set B if every element of set A is an element of set B. If A is a subset of B, we write the following notation. A is a subset of B. So we have that symbol that looks like a C, and that line under it is very important because that sort of C, sideways U, however you want to look at it, without the line under it means something else entirely. Subset A does not have to contain all the elements of set B, but it may. If sets have the same elements, they are called equal sets. So remember from page 1, we had said, there was a particular note. We said that order wasn't important. Apple, banana, pear was the same as pear, apple, banana. So since those have exactly the same elements, those would be considered equal. Alright, so let's consider set A, which has 0, 3, 6, 9, 12, 15. Set B has 0, 6, 12, and set C has elements 12, 6, 0. They are asking if set A is a subset of set B. Well, every single element in A would have to appear in set B. So 0 is in B, check. 3 is not in B, so I don't have to look anywhere else. So that is a no. They're asking if B is a subset of A. So is 0 in set A? Yes. How about 6? Is that in set A? Yes. How about 12? Is that in set A? Yes. Since every element in set B is the element of set A, we can say that B is a subset of A. Is set B equal to set C? Now, let's remember that if sets have the same elements, they're called equal sets. So we have 0, yep, 6, yep, 12. So yes. Now they're asking if set A is equal to C. I think we can see here that set A has quite a few more elements than set C. So that is a no.